Hello, in this video we will cover the basics of water mapping. I will discuss how to make an initial water map, some different ways to collect water usage data, and a preliminary analysis for potential savings. Water flow maps are a powerful tool for any facility. They allow you to identify consumption patterns and spot areas of concern. When creating a flow map, always start where water enters the facility. Then gradually work your way forward following the flow direction and noting all divergences from the main line. Next, write down which process or equipment is fed by each of the branches. With this information, a visual representation of the system can be created. For the purposes of this video series, we will use a moderately simple map that focuses on the big picture mapping. But as you can imagine, once all machines and processing equipment in a given area are added, it is possible for these maps to become quite complex. Once the initial water map has been created, water usage data must be collected for different areas or processes in your facility. One of the most accurate ways to measure water usage is with an analog or digital inline water meter. Meters like these are fairly easy for maintenance staff to install and cost anywhere from $50 to $500. In general, these meters will be more expensive as the pipe size increases. When inline meters are not already installed and you do not wish to install them, there are several other methods you can use to map water. The first and arguably easiest option is to simply use a bucket and stopwatch to measure the flow rate. This method will only be effective for small to medium flows. As a rule of thumb, a minimum of 30 seconds should pass before the bucket is filled to the top with water. Shorter trials can result in a larger error when calculating the flow rates over an extended period of time. The second option is to look for information in equipment manuals and specification sheets. Pieces of equipment that constantly use water will often have specified flow rates included in their documentation. This is always an acceptable way to determine water usage unless the equipment has been modified heavily and operates outside of the normal parameters. Another option is to use an external flow meter. Ultrasonic flow meters such as this one can be pricey. Depending on the model and included features, these meters can run from $500 to $5,000. However, there are some advantages to this more expensive option. Their portability, accuracy, and data storage capabilities may appeal to some people. Once water usage data has been collected, a preliminary analysis may be performed. At this point, it is important to confirm that all data has consistent units. Anything from gallons per second to gallons per year is acceptable, but we will be using gallons per hour in this video. Not doing this will result in errors and an inaccurate analysis. After units have been checked, add all data to the initial flow map like so. With these values inserted, it is fairly easy to see which parts of your facility hold a greater potential for savings. In general, processes that use the most water or have multiple added costs like pretreatment, heating, and high organic loads have a greater potential to lead to savings. For example, in this water map, process number 5 uses a significantly larger volume of water than any other process, and process number 2 utilizes hot, softened water with additional chemicals. Both of these flows have a greater potential for savings than others. Thanks for watching. The next video in this series will address the relative cost chemicals and pretreatment processes add to water.